In this video, I am going to explain about acid, bases and salts. This is the chapter, and in the last video, I explained the behavior of acid with metals and carbonates and hydrogen carbonates. Now, how do acids and bases react with each other? Okay, acids and bases, they react with each other to produce salt and water, right? And this reaction is called neutralization reaction. This is called neutralization reaction. The reaction of acid with base is called neutralization reaction. And the salt is the product formed when an acid and bases react with each other. Okay, now the reaction of metallic oxides with acids. First, let me tell you about the oxides. Okay, there are three or four oxides are there, but we have to study of three of. So one is the acidic oxides, basic oxides, neutral oxides, and amphoteric oxides. Okay, so acidic oxides, basic oxides, neutral oxides, and amphoteric oxides. So there are three neutral oxides. They are, one is carbon monoxide, that is called CO, carbon monoxide. This is a neutral oxide. Other is hydrogen oxide, and we call it water, H2O, water. And third is nitrous oxide, that is N2O. So these are neutral oxides. So they are neither acidic nor basic in nature. Once again, I am repeating here now. The oxides, carbon monoxides, then hydrogen oxides, and then this nitrous oxide, N2O. So these three oxides are neutral oxides. Now, metallic oxides. So metallic oxides are basic in nature. Okay, it's because metallic oxides react with water to make base. Okay, metallic oxides, they are basic in nature. These oxides react with water to make base. For example, sodium oxide, when react with water, it produces sodium hydroxide. Similarly, calcium oxide, it reacts with water to produce calcium hydroxide. So they are basic in nature. Then comes the acidic oxides. So acidic oxides are non-metallic oxides. Like CO. Okay, CO. So, like CO2 it is. CO2 it is here. Carbon dioxide, it is an acidic oxide. SO2, sulfur dioxide, it is also a acidic oxide because carbon dioxide reacts with water to make hydrogen carbonate. That is called hydrogen carbonate. That is called carbonic acid. Okay. Then sulfur dioxide reacts with water to form hydrogen sulfide. It is okay. So these are the acids. Therefore, non-metallic oxides are acidic in nature, right? And then next it is amphoteric oxides. So amphoteric oxides is like this zinc oxide, like aluminum oxides. So these two oxides that we have to study are amphoteric oxides. Okay. Now the reaction of metallic oxides with acids. So metal oxides plus acids they form salt and water. metal oxides with water, with acids, metal oxides with acids forms salt and water. Okay, just I'm showing you by writing. So metallic oxides, just you can say here now, sodium oxide plus water. You will get sodium, you will get sodium hydroxide, you will get. So, okay, this is sodium, this sodium oxide plus water. This you will get sodium hydroxide. This is sodium hydroxide. You can see, just you can see this is sodium hydroxide. Okay. So one is a salt. I'm sorry. We have to. Okay, this is about the metallic oxides. How do these metallic oxides form base? So that I have shown. Now I'll show you metal oxides and the acids. Metal oxides and the acids. Metal oxides and acids. This I'm showing you. Metal oxides and acids. Like metal oxide N2O plus acid. It is acid. Acid means HCl. So you get sodium chloride plus you will get water, you will get. Okay, 42 here and 42 here. So this is we are getting salt, the salt that we eat at home. Okay, that is called like this. It is sodium oxide. When react with acid, it forms salt and water. It's like this. And one more I will show you. For example, suppose how do sodium oxide react with sulfuric acid? Let me tell you. How do sodium oxides react with sulfuric acid? So that is H2SO4. So this you will get sodium sulfate, you will get sodium sulfate plus water, you will get water. Okay, equations must be balanced always. It is here, this is sodium sulfate, this is a salt, this is sodium sulfate, this is a salt, right? This is a salt, yeah, this is a salt, sodium. Now the next one, it is how do metals react with bases? How do metals react with bases? It's okay. How do metals react with bases? So let me show you how do metals react with bases. Metals. So zinc and this sodium. Okay, zinc plus sodium hydroxide. Zinc plus sodium hydroxide. Okay, we'll get sodium zincate. We'll get sodium zincate. Sodium zincate you will get, and we'll get hydrogen gas. This is sodium zincate. Sodium zincate you will get. It is like this. See, sodium, let me balance it. It is 2 here. I think it is balanced. Yes, it is balanced now. Just you can see here now. This is okay. This is sodium zincate. It is also a salt. This sodium zincate is also this is also a salt. Okay, this is a salt. Yes. So now the next it is here. I am showing a reaction with aluminium. It's okay. Aluminium, just I am showing you. Now the reaction of aluminium with sodium is like this. Aluminium and this sodium. It is like this. Okay. Aluminium reacts with sodium The aluminium reacts with sodium to form sodium aluminate. It is like this. See here. It is like this. Okay, aluminium reacts with sodium to form sodium aluminate. Right. So, how do metals react react with base? So this zinc and the reaction of zinc and aluminum with base is important one. And next it is, so how do metal compound carbonates and metal hydrocarbons with acid, that's what I'm told. So now, so that was now a reaction of non-metallic oxides with base. Non-metallic oxides with base. See how what happens. So reaction of base with non-metallic base is same as, both are non-metallic oxides are also basic in nature. These non-metallic oxides are basic in nature, and base is base itself here. So I think the reaction is not so important here. They usually don't react. For example, suppose if I say, okay, reaction of this sodium hydroxide, this sodium, see here, sodium hydroxide react with carbon dioxide to produce salt and water. Salt and water. This reaction is same as reaction between bases and acids. Right? This is the same, the sodium hydroxide, and therefore CO2 behaves as a acidic oxide. So we get sodium carbonate and water. This is the reaction. This is the reaction. This is the reaction. This is the reaction. It is. Okay. This is the reaction. Yeah. Yeah. So now the next question is, what do all acids and all bases have in common? Okay, the acids and bases are quite different, but we have to find out what is common in between acid and bases. It's okay. What is common in acid and bases? So the common between acid and bases is that when acid and bases, okay, they ionized in water, both. They ionized in water. They get ionized in water. Means, suppose, for example, suppose this, if I say, like, suppose it is, suppose HCl. If HCl is dropped into water, it will form, first of all, it form hydrogen ion and this chloride ion. It's okay. Hydrogen ion and this chloride ion will form, or better we can say hydrogen ion will combine with water to form hydronium ion. You can say hydronium ion. So just I'm showing you. So HCl, when it will form hydrogen plus this chloride ion. Look at the formation of this is when HCl is dropped. HCl is a hydrochloric acid, is a strong acid. It gets ionized completely, and therefore the formation of hydrogen and chloride ion. Again, what will happen here now? This hydrogen ion will react with water molecule to form hydronium ion. This is hydronium ion. Okay, this is hydronium ion. It is So this is hydronium ion. It will form hydronium ion. Right? This is hydronium ion, you can see. So overall reaction can be written like this. It is overall reaction. So HCl plus water, you will get hydronium ion plus chloride ion. This is overall reaction. Okay, this hydrogen will get cut here now, so you'll get hydronium ion and this chloride ion. This is the reaction, the final reaction that I have added up together. This is the final reaction. Okay, this. Yes, one important thing about this hydronium ion is that hydrogen ion is that hydrogen ion cannot exist alone. This hydrogen ion that is formed here now here, this is hydrogen ion formed here. It cannot exist alone. Therefore, it immediately combines with one molecule of water to form hydronium ion. Okay. Okay. The next way, how do these bases hydrolyze in water? So they also form ionic ions in water. For example, suppose this is sodium hydroxide. Sodium hydroxide is a very strong base. This is solid when it is put into water, or you get now sodium ion aqueous plus OH ion aqueous. This is this. You can see here now water, it is water. Okay. This is sodium. This is sodium hydroxide. It is solid form, and water is added to this, or when sodium hydroxide is added to water, it forms sodium ion and hydroxide ion. So, okay, they are in the aqueous form. Okay, metals always form positive ions, always. Okay, always forms, because they lose electrons. That's why they form these positive ions, and non-metals form negative ions because they always accept electrons, non-metals. So this is, so what is in common between acid and bases? So the common between acid and bases is that they get ionized in water, both acid and bases. The strongness of an acid and bases depends on how much they ionize in water. If they ionize completely, that is a strong acid. Hydrochloric acid and sulfuric acids, these two are the very strong. Nitric acid also, very strong acid. They completely ionize in water. Okay, that is why they are very strong. In the same way, sodium hydroxide, calcium hydroxide, potassium hydroxide, so they are also very strong base because they completely ionized in water. Okay, so one more reaction I will show you, the ionization of magnesium hydroxide in water. So MgOH. Okay, this is in solid form. When it is dropped in water, or when the water is mixed into it, it forms, this is magnesium ion, and this hydroxide ion, it forms hydroxide ion. It is aqueous. Aqueous means water mixed. It's okay. Water mixed it is. Aqueous means water mixed it is. You can see this is a balanced reaction. It is just, you can see here now, like this, the ion is like this. Okay, this is like this. Okay, Now, the next it is, the process of dissolving an acid or a base in water is a highly exothermic one. It is very highly exothermic, yes. And you know that acid is, so there is a technique in diluting acid. Okay, acids are diluted by, okay, by dropping acid into water and stirring. Okay, you cannot cast water into acid. That is very explosive reaction it is here. So in order to dilute an acid, we put, we drop by drop we put acid into water and we stir it. Okay, isn't it here? So the dilution of acid is, we should have to take care about it. Okay, and this is an, even if, and the dilution of sodium hydroxide is also a very exothermic reaction. That means, what is exothermic reaction? Heat is involved in exothermic reaction. Heat is involved in an exothermic reaction. And so I explained how to dilute an acid. So acid is diluted by, just by adding acid into water. We add acid into water drop by drop, and we stir the solution like this. It is here now. It is highly exothermic acid. So mixing an acid or base with water results in decrease in the concentration of hydronium ion and or OH ion, hydroxyl ion. They decrease per unit volume. Okay, they decrease. Okay, such a process is called dilution, and the acid on the base is called diluted. It is now. Did you follow? Means when you are diluting in our here, suppose when we dilute acid, okay, by putting water into it, when you dilute acid, when we adding acid into water, so the concentration of hydronium ion decreases. It's okay, and the acidity becomes also weak. The same way, when hydroxide is diluted, okay, in water, okay, the presence of hydroxyl ion, that is OH ion, decreases, and this diluted, this hydroxide, or the base becomes low. It is so they become weak. So in order to get weak acid or weak base, so we have to dilute it, or we add acid into water and base into water gradually. So now we come to an end of this topic. So I hope you will like it and just watch it, and in the next I'll make a video of the strongness of acid and bases. How are they measured? How the strongness of how strong an acid and base is, so that how to measure it, so that we'll do the next video. Okay, thank you.